Right, so it's the theorem of Pythagoras. First of all, I need us to answer the question, where is it used? I'll give you maybe 30 seconds. Write one sentence. Where do we use the theorem of Pythagoras? In your books, please. Right, I know you could start with number 4, but then those questions have to be answered as well. Right, can we share the answers? Like, where do we use the theorem of Pythagoras? What did you say, or what do you think? Where do we use it? Yes. Where? Where do we use it? We use it in maths. Okay. Yeah, we use it in maths. We use it in maths. We use it in all other areas as well, in other subjects as well. Where do you think we use it? We use it in right-angled triangles. Yes, we use it in maths. I could go on and say, where in maths do we use it? Geometry. And then maybe you'll say in geometry or in right-angled. We use it in right-angled triangles. Thank you for that answer. Yeah, we use the theorem of Pythagoras in a right-angled triangle. Please do not use the theorem of Pythagoras if your triangle is not right-angled. So you should see 90 degrees, or you should at least know that 90 degrees exists. Now, when is it used? Please don't say on Monday. When is it used? Yes, Kelly?
When finding the length of the longest side.
When finding, okay. So can I say, I'll write it as you said it. When a side, can I say needed or required? I'm trying to paraphrase what you said. So when do we use it? We use it when a side is missing. So it's in a right-angled triangle, and a side is missing. And maybe you can go on. You can go on and say, given two sides, find the third side. Okay, that I think qualifies the whole thing. So we use the theorem of Pythagoras when two sides are given and one side is missing. Does it make sense? Okay, so we use it to find a side given two other sides. Make sure that you understand that. Right, okay, we'll come to the diagrams later. So to answer number 2, we use the theorem to work out a third side given two other sides. Right, how is it used? I think how is it used will go together with what it states. And to me, that sounds like we are looking for an example. Like, how do we use the theorem of Pythagoras? Maybe can we go to the theorem straight away? And then we can answer these questions using an example. So guys, remember, originally we said the theorem of Pythagoras, this is the thought process. Imagine a right-angled triangle with sides measuring A, B, and C units, and you are drawing squares on each side. So on this side you are drawing a square. So what are the dimensions of this square? If I'm drawing a square using this side here, so what are the dimensions?
A times A times
The dimensions are A by A, right? In other words, every side is measuring A by A. Then you can draw another square using this other side. Obviously, if the side is B units long, then what are the dimensions of the square?
B by B.
So it's B by B, right, like that. So remember, these are squares, so this is 90 degrees everywhere there. Okay, then you can also draw a square using the hypotenuse. And so the square will measure C by C, and so on. And what does the theorem state? I want us to start first of all, you can use A, B, and C to tell me what it states, then we shall try and state it in words. So what does the theorem say? Yes?
The sum of two sides.
First of all, just use A, B, and C. Just give me what it states using A, B, and C.
A squared is A squared plus B squared is equal to C squared.
A squared plus B squared is equal to C squared. Okay? So A squared plus B squared is equal to C squared. You'll notice that A squared is actually the area of this square, B squared is the area of this square, and C squared is the area of that square. Right? Can somebody now state that in words? What does the theorem say in words? From the diagram, it means A squared plus B squared is equal to C squared, and you can reduce that to a triangle. So you can go into the triangle and say, if this is A and this is B and this is C, then A squared plus B squared will be equal to C squared. The thinking is exactly the same. A squared is the area of the square on that side and so on. What does it say in words?
The square on the hypotenuse is equal in area to the sum of the area of the two shorter sides.
Say that again.
The square on the hypotenuse is equal in area to the sum of the area of the two shorter sides.
Okay, the square that is formed on the hypotenuse is an area that is the same as the sum of the squares that are formed on the two shorter sides, right? That is exactly the same thing. What else can you say if you want? The smaller squares, if the areas of the smaller squares are added up together, they will give us the same answer as the area of the big square. So let's look at an example from here, because we are answering the question, how is it used? So I'll remove this and give you a question. So as an example, if this is 4 and this is 3, we can work out x, right? We can work out x. Some of these things are easy. You can just get the answer straight away. So suppose this is 3 centimeters and that is 4 centimeters. Right, how do we find x? How do we find x? Now we are applying the theorem. Yes?
So you want to say 3 squared
3 squared
plus x squared. No, 4 squared.
And so what you add, you need to add the shorter ones, right? 3 squared plus 4 squared, yes, is equal to
X squared.
x squared. Now, guys, this means the same as like somebody would prefer to say x squared is equal to 3 squared plus 4 squared. You guys are saying exactly the same thing, right? Okay. Right, so you can say that. Then,
You want to say 9 plus 16.
so this is 9 plus 16 is equal to
X squared.
x squared, right?
And then 9 plus 16 is 25.
So this is 25. So 25 is equal to
X squared.
x squared.
You want to find the square root of 25.
Right, then you will need to work out the square root. If you do that, what do you get?
5 equals X.
You get 5 is equal to x, or x is equal to 5. Okay, that's good. At times you get something like this. Like you know the hypotenuse this time, and maybe this is 9, let's say centimeters. I want us to find x.
Oh, yes.
Right, give me the equation.
Okay, so
9 squared
plus x squared
plus x squared
plus 10 squared
is equal to 15 squared, right? Like that. You can square the 9 and the 15 now if you want. 9 squared is 81, right?
Yes, sir.
And 15 squared, what is 15 squared?
Let's calculate. Yeah, I know.
Right, then we are looking for x, so we need to now move everything. Like the 81 should be moved to the other side. So this is now 225 minus 81. What is 225 minus 81?
225
It's
144.
100 and?
144.
Is it 144?
Yes, sir.
You used to cheat.
Right, so it's 144. Then you can work out the square root.
Square root is 12.
Therefore, x will be equal to 12, right?
Yes.
Okay.